about what is a periodic table. Okay, and to really know so a periodic table is kind of weird, right? Like, I feel like, have you ever seen another periodic table in another classroom like that before? No, you haven't? It's actually kind of surprising. So a periodic table is like, oh man, it's always so hard to draw with my computer, periodic, let's see, table, there you go. Anyways, a periodic table is sort of, you always see them in all these science classes. It's this chart that we use for all this stuff. It looks kind of weird. There's all these letters on there. Like, what is a periodic table? How did we get it? I feel like there's few other charts that we use as often in science, right? So it all comes back to a long time ago. There was a Russian guy whose name was Dmitry Mendeleev, is how you pronounce it. So let's pull up a picture of him. Ooh, this guy right here. It's okay to look at Wikipedia if you're looking at pictures. Look at him, Dmitry Mendeleev. When you picture a scientist, is that the kind of guy you picture?
No.
Sometimes, right? Kind of a crazy looking guy. So he was a Russian guy, and when he was born in 1834, so he was in the 1800s, and he was a chemist. So he studied chemicals. And he started asking himself really interesting questions. He knew that elements were a thing, I believe. And he got these substances that were kind of pure, that he knew they weren't forming molecules. And he isolated them, and he started realizing that you could sort of group them together into ones that had similar characteristics. So let's take hydrogen. Maybe he knew that carbon was there. Helium. So he would write down on cards the names of these elements. Let's pick another one that we all know. Iron. Do you guys know that Fe stands for iron? Kind of weird, right? I think it's Latin or something. So he was looking at these pure substances, and he was like, I'm starting to realize that if I group them together in a certain way, that I can kind of group them together in like a chart that starts to make sense to me. The chart just starts to make sense. So he realized that hydrogen was super light, and so he put it all by itself in the corner up here. And he was like, helium is also really light, but it's different. It doesn't like to react with other gases very much, like hydrogen does. So I'm going to put helium over here. And he started taking all of the known elements and organizing them in such a way. And after he organized them a bunch, I don't think he got exactly to this periodic table. Yes? Oh, Sam's here. So I don't think he got exactly to this periodic table, but eventually he got a periodic table like this. So he organized all the elements together, and they started to form a grouping that made sense to scientists. So eventually scientists would go on to discover lots of more in-depth ways why the periodic table makes sense. So you see how right here there's a column of 2 periodic tables right here, and over here there's one of 6. And here there's one of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what these things are is, and you don't need to know this for this class, but it's the way that electrons orbit around an atom. So they like to group together. And so the first grouping they form is a grouping of 2 electrons. That's the most simple one. And then there's a grouping of 6 electrons, and then there's a grouping of 10 electrons. And so as you're filling up these groupings of electrons, the properties of the elements change. The chemical properties change. So the number of bonds they like to form change. What types of elements they like to bond with changes. So so without even knowing it, this crazy looking Russian guy right here, I don't even think he knew what electrons were. He might have, but I'm not sure. I don't think he knew about the way electrons filled up like that. But he started grouping them together in the perfect pattern that represented the way the electrons fill up their shells. Okay, does that make sense? So the periodic table is this really awesome tool that scientists can use to learn about how elements bond together, how they similar characteristics. For instance, we're going to learn about this more later on, but if you nitrogen and phosphorus, you see how nitrogen is exactly above phosphorus? They actually have very similar chemical properties because they're right next to each other, okay? Oxygen and sulfur have similar properties. Fluorine and chlorine have similar properties. Beryllium and magnesium have similar properties. So this chart, you're going to learn a lot more about it as you learn more about chemistry, but it's a way for us to understand elements so much better than we would if we didn't have it, okay? So this chart, the periodic table, is really important to help us understand elements, and there's a couple of parts of it that I'm going to look at a little bit more in depth with you guys. So this part right here we already talked about, but I'm going to talk about it again. This is called the what? Do you remember what it's called? Atomic number, that's right. So I'm going to draw, oops, I don't want to see Dimitri anymore. So this is going to be the card for beryllium. So beryllium, I think we're talking about beryllium, right? Yeah, beryllium. Keep clicking on Dimitri on accident. Sorry, Dimitri. Okay, beryllium, the atomic number is 4. The symbol for beryllium, you guys know what a symbol is, right? Yeah. So it's just like the abbreviation for the type of the element. So the atomic number up here, and what does the atomic number represent? Not how many electrons, although that can be true sometimes. Close. It's not electrons, that's similar to electrons. Protons, that's right. The atomic number, so painful to write like this. And that's the number of protons, okay? So how many protons does beryllium have? 4. That's exactly right, 4 protons. Okay? Protons. Okay, so that's the atomic number, and that is important because it helps us to draw the element correctly. It helps us to keep the right number of protons when we're drawing out the element. And where'd the periodic table go? Okay, and then this number underneath is something else. Does anyone remember what this number is?
It's something number.
It actually, well, it starts with atomic. Atomic weight, you got it. And who remembers what the atomic weight is?
How many protons and neutrons?
Yes, that's exactly right. Oops. Atomic. Goodness gracious, that is just terrible, isn't it? It really is. I should just find a way to type. It would be better. Atomic weight. Okay, and that's the number of the average number. All right, AVG for average. Protons and neutrons for each beryllium. Okay. So, by the way, so how many protons or how many neutrons does beryllium usually have? If it has 9 protons and neutrons normally, has 9 particles in the nucleus, and then 4 of them are protons, that's right. It normally has 5 neutrons. But sometimes it has more because it's 9.01, which means sometimes it has 10. So I think we'll probably learn about this more next project or later on, or we might not even cover it this year. But the beryllium that has a different number of neutrons than normal is called different isotopes. So for instance, beryllium 9.
Do you have any that
Yes, Sam. Sam has not taken it.
Okay.
Sam, do you want to go take your picture right now? Yeah. Okay, beryllium 9 means it has 4 protons and 5 neutrons. Beryllium-10, you see how it's 9.01, so sometimes it has 10 as its atomic weight. 10 means it has 4 protons and how many neutrons?
5.
Well, 4 plus 5 is what number?
9.
So what would it have to be to get to 10?
6.
6, that's right, yeah. 4 protons and 6 neutrons. That's right. And these two different types of beryllium are called isotopes, okay? Isotopes. So for instance, have any of you heard of carbon-13 dating before? I believe it's carbon-13 dating. It's a way that scientists can measure the number of carbon-13 that is in like plant matter or wood or leather, and they can tell how old that wood is. Does that make sense? So they can measure the number of carbon-13, because usually it's carbon-12, that's the normal type of carbon, but sometimes they have carbon-13, and if the number of carbon-13s goes down over time, so if they measure the amount of carbon-13 that's in a piece of wood, they can tell how old the wood is. And so, for instance, when they discover like an archaeological site where cavemen were, they can use carbon-13 dating to say, oh, this site is 20,000 years old, or whatever. They know how old the site is. Pretty cool, right? Okay, so this is the periodic table. That's atomic number. That's atomic weight. It's this really, really useful tool that we have to learn about chemistry, and you're going to use it a lot as you go on and learn more science throughout your lives as students. Okay, any questions before we end the video? Nope, feeling pretty good?